Okay, and we are live. Yeah, I'm streaming this on YouTube. Yeah.
I'm gonna join it on YouTube.
Well, if you were to subscribe, you would get the notification. But since you guys are haters and you would not subscribe.
Make sure you click the like button and subscribe to the channel. Like, I'm not subscribed to this.
Let me guess.
Wow.
What's it called? Chemistry Man 225. What is it?
I think it's like
It's just my name, Anand Salodkar.
oh, you're
ANAND, like and. And last name Salodkar, SALODKAR.
Why is your picture that though?
What do you mean? Yeah.
Hey, YouTube.
Should I say that?
Are you live?
I am live.
This one on YouTube?
Yes.
Yo, I'm gonna be so famous.
Okay. So,
You got a video of teaching.
There's only one person on there.
I'm a lot.
acids and bases, right? So, okay, guys, just come on. So, acids and bases are a special group of chemicals with some very unique properties, right? So, have you heard of the term acids before?
Yes.
What's an acid? Like a drug? Yeah. Does anyone know what's the actual name? Like when you say acid, what is it? What drug are you talking about? It's an abbreviation. It's LSD. Ever heard of LSD?
Of course.
Yeah. LSD stands for lysergic acid diethylamide.
Wait,
LSD.
if this was lysergic acid diamond, why is it LSD and LSD?
I don't know.
Maybe they were
That
on
makes my
acid,
brain
they were
hurt.
talking about it.
Okay. Some more appropriate acids, however, that I was hoping you would say is citric acid, for example.
Oh, I'm gonna keep it.
Right?
What about sulfuric acid?
What?
Sulfuric acid.
Sulfuric acid. Very good. What do you think sulfuric acid is used? Anyone knows what sulfuric acid is used for?
No. What?
It's used in car batteries.
To make them. Oh yeah, yeah.
Find those.
And then it's citric.
Citric acid is found in pretty much every sour fruit.
That's what we give you.
What is the stomach acid called?
Stomach acid?
Hydrochloric acid. Okay, so these are all pretty common acids. What about bases? Have you come across bases before?
No.
Or are you even aware of what a base is? Nitrogen bases. Where have you heard about nitrogen bases? Very good. Biology, remember?
I heard everything about that. What's the use of
Did they like?
A and T, C and G.
Yeah, I was gonna say that, but
In DNA, nitrogen bases, right? So, what qualifies a chemical as an acid or a base is entirely dependent on its chemical formula and its chemical properties. Okay, so before we get started, we need to note that all chemicals never mind. Can be categorized as either an acid, base, or neutral. Okay. So you can take any chemical under the sun and it will fall into these three categories: acid, base, or neutral, which neutral means something that's neither acidic nor basic. Okay. So let us define the term acid. In the olden days, okay, in the olden days, acid was simply a chemical that starts with H. So if you look at the formula of a compound, and if the, let me put the chemical formula. If the formula of a chemical compound had the letter H as its first element, it was defined as an acid. Now this definition works like 98% of the time, which is pretty good. However, 98% is not good enough for a definition, right? A definition needs to be one that works all the time. So a new definition came in. We will call this the old definition, right? So put the word old in parentheses. The newer, the most updated definition is that an acid is a proton donor. All right, an acid is a proton donor. Any ideas as to what a proton is? A proton is a positive charge. Well, that's true. It does have a positive charge. One thing to always remember, however, is that acids always have to do something with hydrogen. Okay, so let's look at a hydrogen atom. You've got a nucleus inside of which you have a proton, right? Around this, you have the energy level in which you have one electron. If I were to get rid of this electron, what would be left behind? Okay, if I were to get rid of this electron, what would be left behind? Just the proton, right? So a hydrogen ion, which is what you get when you get rid of this electron, is called a proton. Okay, so when you see the word proton in the context of acids and bases, that's what that means. Okay, a proton is another word for hydrogen ion. And one important property about all acids is that they are corrosive. Do we know what this word means? Or okay, the word corrosive means something that can destroy body tissue. Or if it falls on a surface, it will eat away at it. That's what corrosive means. So if you ever look at the label on the battery, for example, it always has a symbol of like hand with like a hole in it to indicate that if this falls on your hand, it is going to burn away at your skin. And what you end up with is a chemical burn. What? What depends on, how much acid and how strong it is. It will probably just like start like eating through your skin and like going inside. I mean, I don't know if it's gonna be like a straight hole, but yeah, it will dissolve your hand. Yes. Okay, so they're corrosive and they're sour.
How do people find that out?
Well, because we eat acids all the time, right? Like probably not sulfuric acid, but we eat vinegar. That's an acid. We eat citric acid. That's an acid. Right? So most acids have a sour taste. Now, granted, you should never try to like taste an acid in the lab, even if it is vinegar. Okay? Because you're not supposed to taste chemicals. Okay. Coming over to a base. A base is a chemical whose formula ends with OH. This is the old definition. And for the longest time, this worked. But then they found out that there are some chemicals that their formulas don't end with OH. And yet their properties are very similar to that of other bases. So they had to come up with a new definition, and that definition is that a base is a proton. What do you think? It's a proton acceptor. Okay? Acids are proton donors. Bases are proton acceptors. So with this much information, what do you think will happen if I mix two acids together? Remember these two statements, and now think about what might happen if two acids were mixed together. Let's say I add an acid A and an acid B together. What will acid A want to do? What do all acids want to do? What? Donate their proton. What does acid B want to do? Donate. So you have two chemicals and both of them want to get rid of their proton. Is that going to work? No. Similarly, what would you think would happen if I mix two bases together? The same thing. They both want a proton. They don't have any protons to give. So an acid can only react with a base and vice versa. Two acids cannot react with each other. Two bases cannot react with each other. Kiera. Okay? As far as like their physical properties go, all bases taste bitter. And the most common examples are medicines. Say that again? I don't know. I don't know how to explain that. Have you never tasted anything bitter?
Like dark chocolate.
Dark chocolate, coffee.
Oh, I like that stuff. It's bitter, but it's not sour. Like sour candy.
There's a
Has a
burger from
different-
Watertown.
Huh?
Nothing.
It tastes like bitter.
No.
Okay. And they're also slippery. Kind of like a soapy texture. Okay? So
You're used to following the
hey, it is what it is, man. I can't help it.
Did you see what I said in the chat?
You're gonna make me disable chat now. What are they called? Super subscribers? No, super subs or something like that.
I can't even watch your live video.
Why not?
Restricted mode.
Why not?
Restricted mode.
Does it say what I said? Oh, yeah, it's fine.
Hey, I got restricted mode. I'm gonna go look it up on YouTube.
That's what I did. That's how I did. Was that what that reminded?
I subscribe to your YouTube. Now you got 91. My YouTube account
Okay. So let's talk about what happens when these two chemicals come in contact with each other. Okay? What happens when an acid and a base react with each other? The reaction is called neutralization reaction. Max, say, put your phone away.
Oh, sorry.
And that's which one is that reaction?
An acid and a base reacts with each other. Okay, so we can say here acid plus base. When an acid and the base react with each other, you get a neutralization reaction. Now, the easiest way to figure out if a reaction is neutralization or not is to just look at the products, right? So let's say, for example, I have a made-up acid called HA. The reason why I know it's an acid is because it starts with an H, right? Which for the most part, all the acid that you're gonna come across in high school level chemistry, they will all start with an H. Okay, so HA plus BOH. So this is a made-up acid reacting with a made-up base. But even though these are made up, we still have to understand that they still play by the same rules. This H is the hydrogen atom, and A is the anion. This B is the cation. And then this OH is the hydroxide. Okay? We know that anions have a negative charge, and we know that cations have a positive charge. So when an acid reacts with a base, your first product that's easiest to figure out is water. Always. No matter what acid and what base you mix together, one product that will always be there is water. Now, how do we figure out what's left? See, water is made from 2 hydrogens and 1 oxygen, right? Where did that come from? That 1 hydrogen came from here, and the hydrogen and oxygen came from here. Okay, because if I cover these two, what are you left with? H2O, right? Now, So we made the H2O. So we got rid of these two already. What am I left with now? A and B. So what formula would you get on this side? No. Yes, why? It cannot be AB. Not that the base goes first, the cation goes first. In any chemical formula, the cation always has to go first. So you would end up with VA. So this is the acid part. This is the base. This is obviously water. And now what we made over here is called salt.
Salt?
Mm-hmm.
Like the table salt?
So it turns out that salt is not a proper noun, it's a common noun. Did you literally just ask me what's a common noun? Like a car or, shirt. Because it could be like, it's just a general term, right? But if I say that a Prius, that's a proper noun, because like now I'm talking about a very specific, like girl is a common noun, but Kayla is a proper noun. Right?
I love that y'all are taking an English star tomorrow.
Yeah. That's very encouraging. Or you can just learn your English.
Evans, I think you should give your friends your word.
So
Just a little.
So salt is any chemical that is made from metal and a non-metal. That's it. So salt is a generic term. The kind of salt we eat is sodium chloride. And if you look at the formula of sodium chloride, does this formula satisfy this condition? The sodium is a metal, chloride is a non-metal. Some other salts we use regularly are Epsom salt. Y'all know what that is?
Yeah.
Epsom salt is magnesium sulfate. You don't eat that salt, but you put it in like bath water, right? Another type of salt is ice cream salt.
Huh?
Y'all know what that is? Ice cream salt.
Yeah. To make that.
You don't put salt in ice cream, which by the way, yes, you do. You are supposed to put a pinch of salt in everything you cook, no matter if it's a dessert or savory. Everything gets at least a pinch of salt. But ice cream salt, on the other hand, is something you put around the bowl in which you're making your ice cream. So what you do is you take a bowl, mix all the ingredients, and then you take a bigger bowl in which you put a whole bunch of crushed ice along with ice cream salt, and then you put your ice cream bowl in it.
Wait, is it?
Yeah.
Oh, I don't know what it does, but salt makes the ice really
Cold, right? So it decreases the temperature. See, ice by itself is about 0 to -4 Celsius.
Yeah, because it gets so cold that it's like burning.
Colligative properties, something we will learn in AP Chem next year. Okay, you already got your schedule for next year? Ew, why?
I can send you a rock. Send you a rock.
You can eat it.
I gotta taste it and look at it, see what rock Bro, what if it's just like,
What if it's a poisonous ring?
oh well. No, poisonous rock?
I mean,
Okay.
what if the most
So let's take an example of an actual acid-base reaction. Okay. HNO3 plus CaOH2. When you look at these two formulas, do they satisfy the condition for an acid and a base?
Yes.
Yes, because starts with an H and ends with OH. So this is an acid, this is the base. Now when they react with each other, what is the first product that we always write down? H2O. Now when you write H2O in an acid-base reaction, you've got to remember that the one of the H in H2O comes from the acid, and the other H and OH comes from the base. So by writing the H2O, I have already used up my H and my OH. So what am I left with? But which one goes first? Ca has to go first because that is a cation, right? Because that's a metal, and metals always have positive charge. What formula would I get? It's gonna have Ca, it's gonna have NO3, but you need to figure out the correct subscripts. How many positives does calcium have? 2. I know calcium is 2 positive because it's on group 2A of the periodic table. NO3, which is the nitrate ion, which is not on the periodic table, but instead it's on the list of polyatomic ions that we all have in our Google Drives. Does anyone remember the charge on nitrate? It's 1 negative. Okay, so what I have here is a calcium ion with 2 positive and a nitrate ion with 1 negative. What formula would I end up with? So here's how you figure this out. Yes, you do, right? But to understand where that switching comes from, this is my calcium ion. I have 2 fingers, but they're both joined together. What does that indicate? Two positives, right? But they're on the same atom, so I have 2 positives. For nitrate, I have 1 negative, so I just have 1 finger, right? Is that enough to cancel each other out? No. So which one do I need more of? Nitrate or calcium? I need more nitrate, so I add 1 more nitrate. Is that enough to cancel each other out? Because I have 2 positives and I have 1 negatives. So 1 calcium and 2 nitrates, which is basically the same as switching, right? CaNO3, 2. Is that equation balanced? No? Yes? No, because right off the bat, I know I have 2 nitrates over here. I only have 1 nitrate over here. So I'll have to put a 2 in front of the HNO3. So now I have 2 nitrates and I have 2 nitrates. But because I added this 2, now I have 2 H's over here and I have 2 H's over here. So I have a total of 4, right? On the other side, I only have 2. So I put a 2 and now everything should be balanced. Because I also have 2 oxygens over here and I have 2 oxygens over here. I have 1 calcium over here, 1 calcium over here. So everything is balanced. So this is an example of a neutralization reaction. Are you questioning me? So look, you have a 2 in front here, right? So this 2 multiplies the whole formula. So in reality, you have 6 oxygens over here. But over here, you also have 6 oxygens. Yeah. So next time you try to question me. Okay. There's a reason why they call me sensei.
Sensei what?
Sensei Soldier.
At the end of the video,
I should rename my YouTube channel that. Yeah.
And your TikTok.
No, my Snapchat is Nerd Chemist.
You can't change that.
Okay.
You're gonna be like 60, and be like, when I was back in the day, my students made me have a Snapchat. And you're like, oh, what is it? Uncle, Grandpa Sloper? Nerd chemist.
Okay. One last thing we need to go over is look at your acid and base, right? And see if you can figure out the ratio of the acid to the base. 2 to 1. You got that from the coefficients, right? What does that mean? It means that for every 2 moles, right? Every 2 moles of the acid, you need 1 mole of the base, right? For every 2 of these, you need 1 of this. Let's say, for example, that I have a beaker in which I have 3 moles of acid. I have 3 moles of nitric acid. How many moles of calcium hydroxide would I need? Knowing that the ratio is 2 to 1, right? Meaning you need half as much calcium hydroxide compared to the acid. Half of 3 is 1.5. So what is this 1.5 moles of base going to do to the acid? Right, so the word we're looking for is that it is going to neutralize it. Okay, this base is going to neutralize all of this acid. So once you're done adding and mixing this together, would there be any acid left in this beaker? No. Would there be any base left in this beaker? Because what you did is you added equivalent amounts. Okay, you added equivalent amounts of acid and bases. Notice that the word equivalent is not the same as equal. Because did I add equal amounts? No, I added equivalent amounts, meaning based on the mole ratio, I added exact amounts that they cancel each other out or they neutralize each other. Okay, so that is all the basics you need to know about acids and bases. There is a very short Edpuzzle that's for today. It's like a 4-minute video. So just go through that real quick and try to knock that out before you leave.
Don't subscribe to YouTube channel.
Such a hater.
Okay, 2 viewers.